Hello everyone. So in this video I will talk about designing an active first order high pass filter. So I'm going to do problem 14.63 of the book. So in this problem it states that actually it asks for designing an active first order high pass filter. So we know that we want to order a high pass filter, and we know that it is an active filter, not a passive filter. It gave us the transfer function of this filter. So h of s is equal to minus 100s over s plus 10, and s is equal to j omega. Okay, and then it says that you have to use a 1 microfarad capacitor. So in these kind of questions, what you have to do, first of all, you have to be familiar with the typical like circuit for high pass, active high pass filter. So as we have talked about this in class, an active first order high pass filter normally looks like this. So we have a resistor and a capacitor in the input. Then we have the op amp, and we have the resistor RF over here, and here is the rest of my circuit. Alright, so we have VO and we have VI. Here we have RI, CI, and RF, and our op amp. So this is our high pass filter, and then we know that H of omega is equal to VO over VI in this filter, which is equal to minus the impedance at the output over the impedance of the input, as you can see in the circuit. Then what we have to do, we can substitute for ZF and ZI. So as you can see, ZI, which is the input impedance, it is over here. So it's the series equivalent of these two elements. So we're going to have RI plus 1 over J omega CI. Don't forget that we're talking about the impedance. That's why I put 1 over J omega CI here. And then my output impedance, ZF, is equal to only RF. So this is the only element that I have here. Alright, now I can substitute ZI and ZF in this equation over here. So then I'm going to have H of omega is equal to minus RF, which is my Z of F, over RI plus 1 over J omega CI. So why am I doing this these steps? Because in the statement of my problem, I only have the information about the transfer function. So I'm trying to write the transfer function of a typical active high pass filter, and then I can compare it with what I have in the question and then find R and C. Actually, we have C, so we only need to find RI and RF. All right, let's continue here. So that would be equal to minus RF J omega CI over, let me write this I as a subscript so you won't be confused. Then we have RI J omega CI plus 1. Okay, so this is the transfer function for an active high pass filter, first order high pass filter. So note that in your exam that you have on Wednesday, and even your final exam, if I ask you such a question, it doesn't matter if you don't want to go through the whole, finding the transfer function. If you just know or you have memorized that the transfer function for the first order active filter looks like this, it's okay. All right, you can just leave it as it is, unless I ask you to go through that and find it, derive it. So you should be able to do that, but if I don't ask you, it's okay, you can just leave it. All right, so now I have my transfer function, h of omega of the active high pass filter, and then I have h of s that was in the problem was equal to minus 100s over 1 plus, was it 1 plus s? Oh no, it was s plus 10, so 10 plus s. Okay, now in the problem, it also says that s is equal to j omega, as we all know. So I can say that my h of omega here is equal to minus 100 j omega over 10 plus j omega. All right, so now see what I have to do is to compare this transfer function over here with this transfer function over here. Okay, so how can I like compare them together? So I have to have the same type of denominator and numerator, right? The numerator is okay because I have RF CI J omega in the upper one, and then down here I have 100 J omega. I'm not talking about this negative sign because in both transfer functions I have this negative sign. All right, but the denominator of the upper transfer function here, you see that I have 1 plus j omega RICI. But down here, I have 10 plus j omega. So the first thing is that to make this 10 be equal to 1, and then I can compare them. So what I will do, I will factor out a 10 from the denominator polynomial. Then I'm going to have 1 plus j omega over 10. And I have 100 j omega in the numerator. Then I'm going to divide this 100 by the 10 in the denominator. I'm going to have 10 j omega over 1 plus j omega over 10. So now you can see that we can easily compare. Now we have to compare this transfer function over here with the one that we have over here. Okay, so in the numerator of the upper transfer function, I have r f c I j omega, and in the bottom one we have 10 j omega. So these two will be cancelled. I'm going to be left with RFCI is equal to 10. All right, but in the problem statement, it says that you can use a 1 microfarad capacitor. So I will substitute CI by 1 microfarad. So from here, I can say that RF is equal to 10 over CI, and that would be 10 over 1 microfarad, so 10 to the negative 6, and that would be 10 to the 7. So 10 to the 7 is 10 mega ohms. So this is my RF. Now the only element that I don't have is RI, and then I can find that through the comparing the denominators. So the denominator of h of omega over here is RI CI j omega plus 1 is equal to this denominator. So I have 1 plus j omega over 10. Then these two ones will be cancelled, and then the j omegas will be cancelled as well. So from here I have Ri Ci is equal to 0.1, and then I have Ci equal to 1 microfarad. So Ri would be 0.1 over 10 to the negative 6. So from here I will have 10 to the 5 ohms, that is 100 kilo. All right, so now I have Ri, Rf, and Ci, which was given. So I have designed my high pass active filter. Okay, and so in this question it didn't ask for the corner frequency, but I'm going to find it, so it will be a review for you as well. So if I want to find the corner frequency of this active high pass filter, I know that omega C is going to be equal to 1 over RICI, and that is equal to 1 over, so 100 kilo ohm is 10 to the 5 multiplied by Ci, which is 1 microfarad. So it is 10 to the negative 6, and that would give me 10 radians per second. All right, so this is how we can design an active high-pass filter. So if you have any question, you can leave it in the comments down below, and thanks for watching.